Today's daily LeetCode problem today is number of atoms, number 726. When they said this shit was hard, this shit was hard. So we're given a string formula representing a chemical formula, and we want to return the count of each atom. Okay, seems simple enough. The atomic element always starts with an uppercase character, then 0 or more lowercase letters, representing the name. One or more digits representing that element's count may follow if the count is greater than 1. If the count is 1, no digits will follow. For example, capital H to capital O and capital H to capital O2 are possible, but capital H1, capital O2 is impossible. Two formulas are concatenated together to produce another formula. For example, H2O2HE3Mg4 is also a formula. A formula placed in parentheses and a count optionally added is also a formula. For example, parentheses H2O2, parentheses H2O2, parentheses 3 are also formulas. We want to return the count of all elements as a string in the following form. First name in sorted order, followed by its count, if the count is more than 1. Followed by the second name in sorted order, followed by its count, if the count is more than 1. And so on. The test cases are generated so that all values in the output fit in a 32-bit integer. Holy moly. We have a couple examples here. So we have H2O. Our output is H2O because the elements are H2O1. Formula is MgOH2. Our output is H2MgO2. Jesus. The count of the elements are H2Mg1O2. Formula, I'm not reading all that. You get it. We have to sort it, count it, calculate it, determine how long the strings are, all the patterns, all that good stuff. We have a hint and the topic, so we could use a hash table, string, stack, sorting. We definitely have to sort. And our hint is to parse formula of I. When we see a bracket, we will parse recursively whatever is inside the bracket up to the correct closing ending bracket, and we'll add it to our count, multiplying by the following multiplicity, if there is one. Otherwise, we should see an uppercase character. We will parse the rest of the strings, parse the rest of the letters to get the name, and add that plus multiplicity if there is one. Cool. By far the easiest implementation for this problem is to use a stack. However, you can also use regex. Regex basically does pattern matching, replacing, and splitting of strings. However, I'm very beginner with that. So the approach we're going to take is kind of a reverse scanning approach. If you want to, you can look at the editorial. They have a really good reverse scanning approach, which is very similar to what I'm going to implement. So by using a reverse scanning approach, this simplifies our addressing of parentheses. Because if you're going to be going from left to right, doing a parentheses, you're either going to have to take note of all of the elements that appear in a formula, and then go back once you find your multiplier and apply it to all of these elements. By using a reverse scanning approach, you can find your digit and then automatically assign it once you've hit that parenthesis, and then you can apply it to each of the letters or each of the elements, atoms, whatever, as you come across them. So for this problem, the algorithm is going to be initializing an integer that is going to be our running multiplier, and this running multiplier will be applied to all of our atoms. It will be set to 1 because before we encounter any parentheses, we just need to multiply, let's say, h times 1 times 2, kind of. So we're not going to be doubling it or anything. There's only 2 of them, so we do h times 1 times 2. So we get 2 h's. We're then going to use a stack so we could store the multipliers as we come across them. So automatically we're going to push 1 to the stack. And while we address through the string, we can peek into the stack, see whatever multiplier is on top. So when we push 1 to the stack, the product of the elements in the stack will be the valid multiplier for the atoms that are scanned, which is also going to be stored in our running multiplier. So whatever is the peak is going to be what we're going to multiply it by. We're also going to initialize a hash map to store the count of the atoms. We're going to initialize strings of our current atom and our current count to store the current atom and current count. We're going to traverse this from right to the left. So we're going to use a public integer that's going to be our index as we traverse the array, or the string, sorry. Then we will use our logic to determine what to do next. If we come across a digit, then we're going to prepend it to our current count. If it's a character, if it's a lowercase character, we'll add it to our current atom. If the character at the current index is a uppercase letter, we'll prepend it to current atom, and now the current atom is complete, so we can use the multiplier that we found on it and store it. So we're going to add our current atom to our final map if the current count is not empty. The value of the current atom will be the product of current count times the running multiplier. Otherwise, the value of our current atom will be whatever the running multiplier is. We'll then need to reset our current atom and our current count, which means it will need to be defined in whatever loop that we have. Then if the character at the current index is a right parenthesis, the current count, if any, is going to be considered as the current multiplier. If the current count is empty, the current multiplier will be 1. We'll then push our current multiplier to the stack, multiply our running multiplier by our current multiplier, and reset our current count, because now we have a new multiplier that's in play. If the character at the current index is a left parenthesis, we just simply need to divide by the running multiplier. So by keeping track of our running multiplier, we can always get back to whatever we previously had. So we'll divide it by the popped element in the stack, get back to whatever our previous running multiplier was. Finally, we're going to sort our map using the keys. We're going to generate our answer using a string as we iterate over our sorted final map, and append the atom to the answer, 1 atom at a time, as long as it has a count greater than 1. Then we simply need to return our answer. Very simple. Very, very simple. So, how do we do this? So we're going to have an integer running multiplier. It's going to be equal to 1. And then we're going to have a stack of integers. Call it S is equal to a new stack. Then we're going to stack dot push 1. So we're pushing 1. We're pushing 1 because at the end of the day, 1 is our base multiplier. If there is no parentheses, we're not going to be changing this multiplier. Now we want to initialize our map. So map, and we're going to be storing strings and integers. It's going to be whatever the string is the atom. Integer is the count of the atom. So we could call this final is equal to a new hash map. Then we could use a string builder to address our current atom and a string builder to address our current count. So now we need to find our index. Because we're going to be traversing this in reverse, we are going to set our int index is going to be equal to formula.length minus 1. Because it is a 0 indexed string, so it means it starts at 0 and it will end at formula.length minus 1. Now we simply need to parse formula. So while our index is greater than or equal to 0, so from end to beginning, if our character is digit, means that it's a number, the character itself is a number, 1, 2, 3, 4, 5, then our formula dot char at index, we're going to do current count dot insert 0, and then formula dot char at index. So we're inserting that onto our current count because it is a string builder. It's going to be at the front. It's empty currently. Then, if we encounter a uppercase letter, we want to address our map because we just completed an atom. So else if character is, we're going to address a lowercase letter first. If we encounter a lowercase letter, we want to append it to our current atom. We're building our current atom. So if it is a lower case letter, then we're going to do formula dot char at index, and we're going to add it to our current atom. So cur atom dot insert 0, comma, that means position 0. So when we're inserting it, we're inserting at position 0. 0, comma, formula dot char at index. Cool. Now we have 5 possible outcomes. We have a ending parenthesis, opening parenthesis, lowercase letter, uppercase letter, and a digit. So this is our digit. This is our lowercase letter. So now we can do our uppercase letter. So else if our character dot is uppercase, formula dot char at index. Then what we can do is current atom dot insert at the 0 position, our formula dot char at index. But because this is an uppercase letter and we're traversing from the right to the left, that means we just completed an atom. So we're going to need to address the fact that we completed an atom, multiply whatever current multiplier we have, and do all that good stuff. So we're going to have an integer count, which is going to be equal to our current count dot length, as long as it's greater than 0. Otherwise, or if that is the case, our integer, integer dot parse int cur count dot to string. Otherwise, if it is not greater than 0, then it's just simply 1. We're going to multiply it, or our count is going to be set to 1. There was 1 of that atom. So now we need to address it and add this atom to our final map. So we're going to have final dot put probably shouldn't have made it final. We'll do final map. Final map dot put. We're going to put our current atom dot to string. We're going to put our final map dot get or default current atom dot to string. So if there was previously this atom added, we don't want to reset it to 0. So we'll either add it to 0, or we are going to add our, if it's greater than 0 in this case, we're going to add our count times running multiplier. What do we call it? Running mul. Yep. So adding to our map, we're going to add our string, whatever atom it was that we determined it was, our current atom, to string, and it's either going to be 0, we're going to default it at 0, and then add our count however many times we counted it, times our running multiplier if it happens to be in parentheses. So that's it. Then we're going to set our current atom is equal to a new string builder. Go ahead and set this back to default. And set our current count back to a new string builder. So empty both of those because we found our atom. Now, if we encounter a right parenthesis, we're going to do an else if the formula dot char at index is equal to a right parenthesis. So our second to last scenario, we're going to increment our multiplier. So int current multiplier is going to be equal to our current count dot length, as long as it's greater than 0. If it is greater than 0, it's going to be integer dot parse int our current count dot to string. So it's going to find whatever that's worth numerically. Otherwise, it's going to be 1. Then we could do a stack dot push because we now have a new multiplier. So we're going to push this to the top of our stack so we can remove it later on once we reach the end of our parentheses. So we're going to have current multiplier, push that onto our stack. And our running mul is going to times equal our current multiplier. Then our current count is going to be reset to a new string builder because we moved on to a new multiplier. Now, last situation is if we have a left parentheses. So else if formula dot char at is going at index is going to be equal to a opening parentheses. That is going to end our whatever current multiplier is there. So running mul is going to divide and equal stack dot pop. And then we simply need to increment our index. So we're going negative, so index minus minus. So that is our while loop. That addresses our 5 case scenarios: digits, lowercase letters, uppercase letters, closing parentheses, and opening parentheses. Now we simply need to organize it and sort it for when we return it. So we're going to have a tree map. Because tree maps are automatically sorted, string integer sorted map. It's going to be a sorted map because that's what tree maps are. They're sorted maps. So new tree map, and it's going to be a map of our final map. Now we just need to turn this tree map into our answer string because we have to return it in a string. So string builder answer is going to equal a new string builder. So for each string atom in our sorted map dot key set, so each key, our answer is going to append each atom. And if sorted map dot get atom is greater than 1, so if we have more than 1 as our value, we can append their key value pair as well. So append sorted map dot get atom, and that will either, because if it is equal to 1, we don't want to put the numerical value there, right? We're just going to put mg because there's only one mg. But if it's greater than 1, we can append their value pair. Now we simply should be able to return our answer dot to a string because it was a string builder. And if we run this, so this passes our test cases, and it passes all solutions. Let's go. I'm going to just do the Python solution really quick. It is basically the same exact thing, kind of, sort of. I'm going to just do the, what's it called? Syntax for it. So we're going to have a running mul equal to 1, stack is equal to, we're going to have 1 in the stack already. Final map is going to be equal to default integer, current atom is equal to nothing, current count is equal to nothing, index is equal to the length of formula minus 1, while index is greater than or equal to 0, if formula of index dot is digit So we run this. Pass our test cases. Passes all solutions. So thank you and follow for more daily LeetCode solutions.